Hello everyone, welcome to Beyond the Classroom. Today we will be looking at the second part of Lesson 1, which is numbers up to 10,000. In the first part of this lesson, we learned how to read 4-digit numbers. We also studied how to represent and read numbers on the abacus, and we also learned number names and numerals for 4-digit numbers. So let's continue with part 2. In this part of the lesson, we will learn the face value of a digit in a number, the place value of a digit in a number, how to express a number in expanded form, and what is the successor of a number and a predecessor of a number. Now let's understand what we mean by face value. Now, the face value of a digit in a number is the value of the digit itself at whatever place it may be. So, what this means is that the number may be in the ones place, the tens place, the hundreds place, or the thousands place. Irrespective of whichever place it is in, the face value of a digit is simply the value of the digit itself. To understand this better, let's take an example. Here we have the number 6,897. So let's look at the face value of the different digits in this number. The face value of 7, which is in the ones place, is 7. It doesn't matter, even if the 7 was in any other place, its face value would still be 7. The face value of 9, which is in the tens place, is 9. The face value of 8, which is in the hundreds place, is 8. And the face value of 6, which is in the thousands place, is 6. So, I repeat, the face value of a digit is the number itself, irrespective of which place it is in. Now let's look at what we mean by place value of a digit. Now the place value of a digit in a number, it depends upon the position in the place value chart. So to understand the place value of a digit, we need to know at what position the digit is in, whether it is in the ones place, the tens place, the hundreds place, or the thousands place. Okay, so to understand this better, let's take an example. Here we have the number 7,348. 7,348. Now let's understand what is the place value of the different digits in this number. The place value of 8. Now look at where 8 is placed. 8 is placed in the ones place. The place value of 8 is 8 ones. And when we say 8 ones, what do we mean? It simply means 8. So the place value of 8 is 8. Now let's look at 4. 4 is placed under the tens place. So the place value of 4 is 4 tens. And what do we mean by 4 tens? 4 tens is nothing but 40. So the place value of 4 is 40. Let's look at 3. The place value of 3, which is placed in the hundreds place, is 3 hundredths. And 3 hundredths is written as 300, 300. So the place value of 3 is 300. The place value of 7, which is in the thousands place, is 7 thousandths. 7 thousandths, which is equal to 7,000. Hence, we now understand that the place value of a digit will depend on its position, at which place it is in the place value chart. Now let's look at some examples and try to write the face value and place value of the digits in the given numbers. Children, at this point, what you can do is you can pause the video, see the problem and try to solve it. And then after you have done your book, you can come back and check the answer. So let's look at the first example. So it says, write the face value and place value of 8 in 5,806. Now first, we will look at the face value. Now, the face value does not depend on the position. It is just the value of the number itself. So, face value of 8 is 8. Now, let's look at the place value. Now, the place value depends on the position. Now, since 8 is in the hundreds place, the place value is 8 hundredths. Right? Now, let's look at another example. Let's try to write the face value and place value of 3 in 3,896. The number is 3,896. Again, the face value is the value of the number itself. So, the face value is 3. The place value will depend upon the position of the number. Here 3 is in the thousands place. So the place value of 3 will be 3 thousandths. That is 3,000. 3 followed by 3 zeros. So that is how we write the face value and place value of a digit in a number. Now let's look at how we can express a number in expanded form. Now, when we take a number and express it as the sum of the place values of its digits, we say that it is an expanded form. Now, this definition might seem complicated, but it's really not so complicated. It's pretty simple. So let's look at an example to understand this better. Let's say we have the number 9,652. Let's write this in expanded form. So this can be written as 9 thousandths plus 6 hundredths plus 5 tenths plus 2 ones. And we simplify it even further and we write it as 9,000 plus 600 plus 50 plus 2, just in numbers. So this is the expanded form of this number. And if we are given this number in the expanded form and we write it in the above form, then we call it the short form. So we say that the short form of 9,000 plus 60 plus 50 plus 2 is nothing but 9,652. So this is how we write a number in expanded form and short form. Now let's try out some problems to write a number in expanded form. Again, you can try to solve this in your notebook, pause the video, and you can come back and check your answer. So let's look at the first example. So let's write 5,000, there's nothing in the hundreds place, 5,063 in expanded form. So here we go. We have 5 thousands plus 0 hundreds plus 6 tens plus 3 ones. Now, if we want to write it only in numbers and not in words, we simplify it as 5,000 plus 0 plus 60 plus 3. And since 0 has no value, we can remove it and we can simply write 500 plus 60 plus 3. So 500 plus 60 plus 3 is the expanded form of the number 5063. Let's look at another example. Okay, the answer is already popped up. No problem. So we are going to write the number 2746 in expanded form. First, we write it in words. 2000s plus 700s plus 4 tens plus 6 ones. Now we write it in numbers. 2000 plus 700 plus 40 plus 6. This is the expanded form of 2746. Now let's try some examples of writing a number which is given in expanded form in short form. Here we have the number 2000 plus 700 plus 40 plus 6. Now looking at the digits, the numbers, you can see at what place this will come. So 6 will come in the ones place, 4 in the tens place, 7 in the hundreds place, and 2 in the thousands place. That's 2000s plus 700s plus 4 tens and 6 ones. So when we put it in the place value chart, this is how it looks like. This is the short form, 2746. So that is the short form of this. Let's look at another example now. We have 7000 plus 400 plus 0 plus 5. Now, if we look at the place value chart, we know 5 will come in the ones place. There's nothing in the tens place, so we put a 0 in the tens place, 4 in the hundreds place, and 7 in the thousands place. Now, children, it is very important to remember that if there is a 0 in the expanded form, you cannot just leave it out. Some of you might just tend to write 742. Sorry, 745. That's not right. It'll be 7405. Even if there's nothing in the tens place, you need to still put that 0 in the tens place, in the place value chart to complete the number. So that's how 7000 plus 400 plus 0 plus 5 in short form is written as 7405. So that's how we write a number in short form. Moving on, let's look at what we mean by successor of a number. The successor of a number is the number that comes after a particular number. That is called a successor. So you have done these kind of problems in your previous classes in grade 1 and 2. The only difference is that there you did not use the word successor. You were just asked to write the number that comes after a particular number. So it's really that simple. A successor is nothing but a number that comes after a particular number. So let's look at some examples. The successor of 7 is 8 because 8 comes after 7. The successor of 25 is 26. The successor of 953 is 954. And the successor of 1246 is 1247. So all that you do is just add 1 to that number, or you can write the number that comes after. That is the successor of a number. Now let's look at what we mean by a predecessor of a number. Now, a predecessor of a number is the number that comes just before a particular number. Again, you have done this in your previous classes where you were asked to write a number that came before a number. So, it's the same thing. The number that comes before a particular number is called the predecessor of that number. Let's look at some examples. The predecessor of 5 is 4 because 4 comes before 5. The predecessor of 83 is 82, the number that comes before. The predecessor of 768 is 767. And the predecessor of 3257 is 3256. Now let me ask you a question. What is the predecessor of the number 0? Can you think about it? What is the predecessor of 0? So some of you must have guessed it right. That's right. 0 has no predecessor because we do not have any number before 0. Now let's try to solve some examples. Let us try to write the successor of these numbers. You can try to work this out in your notebooks, children. So let's look at the first number. Write the successor of 379. So again, what is a successor? A successor is the number that comes just after a particular number. So the successor of 379 is 380. 568. The successor of 568 is 569. The successor of 999 will be, we add 1 to this. That's right. So the successor of 999 is 1000. The successor of 1207 will be 1208. The successor of 4999, the number that comes after, we add 1 to this, will be 5000. And the successor of 9099 will be 9100. So this is how we write the successor of numbers. Now let's try to write the predecessors of a few numbers. Again, the predecessor is nothing but the number that comes before a particular number. You can also get this by subtracting 1 from that number. So let's take a few examples. The predecessor of 100, 100 is 99. The predecessor of 867 is 866. The predecessor of 5473 is 5472. The predecessor of 2200 is 2199. The predecessor of 9,999 is 9,998. And the last one, the predecessor of 9,615 is 9,614. With that, we come to the end of the second part of this lesson. So thank you for watching and stay tuned as I will be soon uploading the third part of this lesson, which is the final part. Till then, keep practicing. For more such videos, subscribe to our channel Beyond the Classroom. Thank you for watching.